let's get started with this segment. So far in the last segment we talked little bit about training, and then we discussed like different types of neural networks, and then we briefly discussed how a convolutional neural network looked like, right? Again, as you can see that this convolutional neural network has different layers of convolutional operation, and then there are normalization, pooling. Remember, each of the convolutional layer has convolution followed by nonlinear activation, right? So again, as we already discussed that first few layers capture the low level features like edges, intensity, brightness, etc., and the later layers capture the high level features. After that we have the fully connected layers which generate or which classifies the input images into classes. Now let us again talk about computing, right. So remember, whenever we talk about this convolutional neural network, we have to compute something. There are some arithmetic operations going on, multiplications, additions, division, exponential, some arithmetic operation or algebraic operation is going on. Now it has been seen that convolution accounts for more than 90% of the overall computation. So let us say there are total, let us say 10,000 floating point operations are happening in the whole CNN. It has been seen that out of 10,000, 9,000 operations actually come from convolutional operation, right. So that is why it dominates the overall computation, which results into like dominating the runtime as well as the energy consumption. That is why if we can build specific hardware, or if we can do some optimization in the hardware which reduces the latency of convolutional operation, that will greatly benefit the total execution latency of a given CNN, right. Now let us see what exactly this convolutional operation is, right. So remember, the convolutional operation or the convolutional neural network actually is very much useful for images. So let us say we have this input image, a plane of input activation, that is also known as input feature map, or that is denoted as F map. So let us say we have this image, the image height is h and width is w, right. Remember, we mentioned that whenever we have convolutional operation, then we have weights or filters, right. So let us say we have this R by S filter, right. Again, little bit reiteration. So if we just pass this image onto one multilayer perceptron, then all these pixels like h by w, if we have image height of h and image width of w, then we will have total number of pixels as h multiplied by w, right. So all these h multiplied by w pixels will be fed onto the multilayer perceptron or different neurons of the multilayer perceptron, but that is not a correct way to analyze an image, because remember, the neighboring pixel has to be analyzed so that we can know what this image is of, correct. Now so this filter actually helps to analyze the neighbor pixel. Now in this particular case, you can see that we have a filter of height r and then width s. Again, whenever we are saying filter, that means the weights, they have some numbers, nothing more, nothing less, okay. Now let us see how this filter operates on the images, on the image. So what will happen? So this is nothing but the convolutional process. Let us say we have this image, and then let us say we have this filter, okay. So the filter will be projected on the image. That means whenever we say projected, that means we will perform this element wise multiplication. So let us say we have this 3 by 3 filter, then this 3 by 3 filter will be projected on the top left corner of the image on a 3 by 3 patch of the image. So whenever we say 3 by 3 filter, that means we have total 9 numbers in the filter. We have total if we take that 3 by 3 patch, that means all those 9 pixel values are taken, right. Once we project it, then we perform the element wise multiplication. Let us say the filter weights are nothing but A1, A2, A3 etc., and then the image pixels are P1, P2 etc., then we will perform A1 P1 multiplied by A2 P2, A3 P3 and so on and so forth, right. That is the element wise multiplication, and the next step is to add it. So, all those A1 P1, A2 P2, A3 P3, all those products will be added. So, now they are called partial sums. So, those partial sums will be accumulated to produce an output activation, right. So, again we have this filter R by of size R by S, which is getting convolved with an image of size H by W to obtain an output activation of size E by F, right. Now, each pixel of this output activation or output feature map is actually produced by doing all the by sliding that filter on the input feature map. So, let us say we have this input feature map, which is nothing but the input image, then we have these filter weights. We will perform the element wise multiplication and add it to get one number, which is this particular pixel in the output feature map, right. Now, we will slide. So, we have this image. Now, this kernel or the filter will slide, we will go to the next patch of the input feature map or the input image, and then it will produce another output in the another pixel in the output feature map, or that is the output activation. So, once the filter completes the slide through this row, then it will go to the next row and so on and so forth. So, it will slide like this. So, once it slides over the entire image, then we will get the entire output activation. So, that is how this convolution operation happens, right. Now, whenever as I was saying, this is the sliding window process. So, this dotted line is showing the first step, and then in the next step it will get the filter will slide, and then it will perform the element wise multiplication onto the next patch. It will perform the addition, and then it will produce the next pixel in the output activation. So, that is how this convolutional layer or the convolutional operation happens. This is sliding window processing, right. Now, remember, whenever we talk about image, I am pretty sure that you are in Instagram and then you take photos, make reel or post those photos in the Instagram. So, all those photos or all those images have multiple channels. So, typically RGB are the channels in the standard image. RGB is nothing but red, green and blue. If the photo is black and white, then we will have just one channel, but who uses black and white photo, right. So, those images or those photos have multiple channels, they do not have one single channel. Now, since there are multiple channels in the image, we need multiple channels in the filter also, right. So, that is why you can see that again we have this image of height H and width W. Now, we do not have a single channel. Instead of single channel, we have this multiple of the channel, multiple channels. The number of channel is C in this case. Now, at the same time we have, so since we have C number of channels, we need to have C number of channels in the filter also. So, that is why we do not have just one plane of filter of R by S, rather we have R by S by C, right. So, now our filter is 3 dimensional, it is no longer 2 dimensional, correct. Now, if we have multiple channels, what we do is we perform element wise multiplication and then addition for each of the channel, and then that after that we will get one value for each of the channels. All those values will get added across the channels, which will generate one output feature map, right. So, for an example, in this case we have this R by S by C, right. So, each of those pixels will get element wise multiplicated in this output feature map, so in the input feature map, and from each of the projection or from each of the channel we will get one number. So, this will get projected and it will produce one number, and then this the next channel of the filter will get projected on the output feature map, it will generate another number, and then so on and so forth. So, we will add all those numbers to get this output feature map. Okay. So, that is how this convolutional operation happens if we have multiple channels, right. Again the filters will slide in the horizontal direction and the vertical direction, as we were sliding in case of there was one filter, and then we will get the output feature map, right. Now again the story does not end here. So as I was saying that the input does not have only one channel, but it has multiple of channels, right. Yes, at the same time we have multiple of these filters also. As you can see, there are multiple of these filters. Now these filters, or why do we have multiple filters? Because each of the filter try to capture different property of the image. So we have multiple of the filters. Again remember, filters are nothing but trainable parameters. Those weights have already been trained and all those things. If we have many of those filters, then each of the filters, so this is one filter that will get convolved with the input image, and then it will generate one plane of this output feature map. Okay. So each of the filter will generate one plane of the output feature map, right. How it will generate? Again the filters will get convolved, it will be sliding on the input feature map, element wise multiplication is happening, and all the outputs will be, again all the outputs from each of the channel will get added to get one pixel of this output feature map, right. Now from one filter we will get one plane of the output feature map. Since we have m number of filters, we get m planes of the output feature map. So that means the input, the kernel was of size r by s by c, and then we have m number of kernels. So from each of the kernels we get one output feature map of size e by f. Since we have m number of kernels, the effective size of the output feature map will be e by f by m. Okay. So again that means we have many number of channels in the output feature map. So remember, there is no single layer of convolutional neural network, there are multiple layers of convolutional neural network, right. So this output feature map will be the input of the next channel. So again we will have all those kernels in the next layer which will get convolved with to get another of output feature map. So that is how different layers of convolutional neural network happen. Again I mean there is one thing that after this there will be nonlinear activation, some nonlinear function will be there, but yeah. So overall we have multiple of these filters. We have one single input image of, let us say, height of h, width of w, and then c number of channels. So we will get output feature map where the number of channels in the output feature map is same as the number of kernels, right. This is very important understanding which we will use many times in later segments. Okay. Again story does not end here. So whenever, let us say, you use ChatGPT to like get your queries done, right. So remember, you are not the only one who is using ChatGPT. There are several thousand other students who are trying to get their assignment solved through ChatGPT, correct. That means there are multiple queries which are coming to the OpenAI server at the same time, right. Now they are not computing just one query at a time, they are actually computing multiple queries at a time. Now this is called batching. They are creating a batch of multiple queries and then they are executing all those queries at once. So in convolutional layer also we can actually batch multiple inputs. So this part we already saw, each filter is of size r by s by c, and then we have m of these filters. So that number of filter dictates the number of channels in the output feature map. Now from each of the input we will get one output feature map. As I was saying, batching means we are performing the inference on each input or on multiple input, right. So in this case we have n input 1 to n. So if you have n input, of course we should have n output, right. From each of the input we will get one output, but the main point is we can do batching. So in this case we have prepared a batch of n input which will generate n number of output, right. So far let us talk about very high level. so far what we have seen there are multiple of CNN parameters. N is the number of input feature map or output feature map, which is nothing but the batch size. Then we have C, which is the number of 2D input filters, the number of channels. Basically, if we have RGB images, then we have 3 channels for the input images. H is the height of the input feature map, W is the width of the input feature map, R and S are the height and width of the 2D filter. Then we have M, which is nothing but the number of 2D output feature map, which is also the number of kernels or the number of filters. So, remember, the number of filter is equal to the number of output feature map, number of channels in the output feature map. Then we have this E and F as the height of output feature map, which we will obtain from the convolution, correct. Now, remember, at the end there is some program or there is some computer code which is actually executing this convolutional neural network, right. So, this particular figure is showing the overall execution of convolutional neural network, where you have n input, where each of the input has C channels, and then you have m filters. So, that you have n output, where each of the output is of size E by F by m. Why m? Because we have m number of filters, right. Now, if you actually have, or if you actually write the computer program, then it will look like this. So, output feature map will have 4 dimension. O is nothing but the output feature map, which has n, m, x, y. That is nothing but the activation. We have some activation plus this convolutional operation. So, input feature map multiplied by the filter weights. So, we have input feature map I is nothing but the pixel values. We have this ux plus I, ui plus j. This forms the stride length. So, remember, let us talk about the stride length also. Whenever we are sliding that whenever we are sliding the filter on the input feature map, so there is a concept of stride length. So, let us say this is our filter and this is our input feature map. So, let us just say 0, 1, 2, 3, 4, 5, 6, 7, and let us say this is 0, 1, 2, means there are 3 pixels, and this is also let us say 0, 1, 2. So, whenever we perform the convolution, so first this this kernel will be mapped or will be projected on this, and then element wise multiplication will happen, and then we will get the output, right. Now, when we do the next one, if our stride length is just 1, then we can project it here, right, from 1 to 3. If our stride length is 2, then we will project here from 2 to 4, right. So, that is the stride length, like how much stride you will take to perform the convolution. So, this ux plus I and then this ux and ui actually defines the stride length, right. Now, let me erase this part because something is going to come up. So, I hope you understood that at the end of the day, all these convolutional neural network or all these convolutional operation has to be computed, right. So, we need a role of computation, and as you can see, there are too many operations, like too many multiplications going on, right. And eventually we will see that we have to know a technique which will reduce this multiplication or which will perform this multiplication in a very efficient way. Now, at a very high level, we have like inputs, we have n inputs, each of the input has multiple channels. We have the filters, there can be multiple filters, each of the filter is 3D. Filter also has number of channel, the number of channel in the filter has to be same as the number of channel in the input. Number of filter decides the number of channel in the output. So, if you have m filters, then we will have m channels in the output. So, finally, the outputs are also 3 dimensional. If we have n number of inputs, then we will have n number of outputs. So, that is the convolutional operation for you. Now, these parameters, these are some shape parameters which are actually used to compute this particular function. This particular function is, or this particular equation is nothing but to compute each of the pixel in the output feature map. So, we have different many number of parameters like n, m, c, h, w, r, s, e, f, and then finally the convolutional stride u, right. So, as you can see, I mean convolutional operation takes lot of parameters, and then although the computation is simple, the computation is just multiplication and addition, but there is some peculiarity in the computation, right. It is not a simple computation, and again I mean there are stride length, then there are multiple filters, then there are multiple filters is there, channels are there, filters are translated into different number of channels in the output, and so on and so forth, right. So, I mean although the core computation is simple, core computation is just multiplication and addition, but then there is some peculiarity. I mean as you can see, this particular equation is not very simple, correct, because the convolutional operation happens in a particular way, right. So, I hope I mean right now your mind is already blown. So, I will stop here, and in the next segment we will deep dive into more into the convolutional operation. We will take some example and see how they actually work. Okay. Thank you. See you in the next segment.